if a woman carries that mutation of the BRCA gene, that they're more likely to develop breast cancer. So let's take a look at this. What it says here is, in the general population, 1 woman in 8, so that's important there, 1 in 8 will develop breast cancer. Research has shown that approximately 1 in 600 carries a mutation of the BRCA gene. About 6 out of 10 of those women with this mutation develop breast cancer. We're first to find the probability that a randomly selected woman will develop breast cancer, given that this has already happened first, given that she has a mutation of the BRCA gene. The second one says, find the probability that a randomly selected woman will carry the mutation gene and will develop breast cancer. That "and" is going to be very important. And are the events carrying this mutation and developing breast cancer independent or dependent, and explain. So let's take a look at this first. I'm going to let A be the mutated gene because that's what research has shown, that women who carry that gene develop breast cancer. And I'm going to let B develop breast cancer. I let the gene be A because it had to happen first. And then breast cancer developed after they found, the research found that they already had that gene, then they developed breast cancer. So the first one says, find the probability that a randomly selected woman will develop breast cancer given that she has the mutation. Alright, so what we're going to do is we're going to look at these 3 items that I've written here. 1 in 8 women develop breast cancer, and we know that B is developed breast cancer. So this is the probability of B is 1/8. I'm just taking this out of the reading. 1 over 16 is that they carry that gene. So that's what A is. They carry the gene. Then 6 out of 10 have the mutation, which is A, and they develop breast cancer. So this means the probability of B, given that A has already happened. They have the gene, which is A, then they get breast cancer. So that is, that's 8 out of 10, not 6 out of 10. I've made a typographical error there. So that's 8. Okay, so what we're going to do now is we're going to look at this first one. This says that they develop breast cancer given that they already had the gene. So that's B, which is breast cancer, given that A has already happened, and we know that's 8 out of 10. The next question said, find the probability that a randomly selected woman will carry the mutation gene and will develop breast cancer. Anytime you have the word "and" in between the 2 events that are occurring, this is the formula that you have to use. You take whatever the probability 600 and you multiply it times the probability of B, given that A has already happened. And we know that that's 8 over 10. So if you multiply those 2 on the calculator, you're going to get 0.0013. And this is a formula that you will find in section 3.2, and it has to do with the word "and." So if it says "and," you have to use this formula. Now, are they independent or dependent? And I'm going to go ahead and tell you they're dependent. If these 2 are equal, then they're going to be independent. But you have to look at the probability of A, given that B, given that A has already occurred, which we know is 8/10, and you look at the probability of B by itself. And if those 2 numbers were equal, I would have said independent. But since they're not equal, that means that they're dependent on each other.